I'm now going to look at the nitty-gritty details of how to save and load, write and read structured information to and from a binary data file. You'll find this code in 02_CD database. As I've explained already, this program prompts the user to enter single character commands, and when the user enters D, the display_CD collection function is called. That function is in cd Debug C, and what this does, it actually calls the load_CD collection to do the real work, and that's up here. Now, load_CD collection, what does this do? First of all, notice it's been declared as static, and that's because I want it to be private within this code file. It's called, as I've explained, by the public function display_CD collection, but the function load_CD collection itself cannot be called from code outside this code file. Now, this code begins by calling another function, number of records in DB, to return the number of records that are stored in the data file. I'll explain how it does that shortly. Then it tries to open the file in binary read RB mode. If that operation is unsuccessful, the return value assigned to F, that's the file pointer, is null or 0, and I display an error message. Otherwise, F is assigned a pointer to the file, and I read in all the data from the file using fread. The first argument, CD collection, is the array into which the records will be read. The second argument is the size of each item. Each block of data represents a CD struct, so I give its size a size of CD. The third argument is the number of items to be read. And the fourth argument is the file pointer. The returned value is the number of items that were read, and this is assigned to the numRexRead variable. This gives me a way of testing that the number of items which I tried to read and the number of items that I actually read are the same, and if not, due to some unforeseen error, I can display an error message. And when I finish processing the file, of course, I close it. But how did I calculate the number of records that were in the file before I began reading them? Recall that this value was stored in numRex, and I used the variable in two places. As mentioned before, I used it with fread to specify the number of records to read into the array cd_collection. But before I did that, I used it in this line of code. In my previous example programs, the cd_collection array was declared to be of a fixed length. That's in my previous examples when I created CD collections in memory. So, for example, if I wanted to store 4 structs in the array, I declared the array as CD collection and then open square brackets 4, close square brackets 4. But in this program, I don't know how many structs I need to store until I calculate how many records exist in the file on disk. It could be 4, but it could be 400. And I need some way of setting aside enough memory for cd_collection to accommodate all the records read in from the file. To do this, I use realloc. Now, we've used malloc previously to allocate memory for an array. You remember in 01_read file, I allocated enough memory to store characters read from a file in the char array. I can look here, and there's my line of code. B equals, and then I cast char pointer, malloc, and I put the size in parentheses. Now, similarly, in the current project, I use the malloc function to create the CD collection. You can see that up here. That's my default CD collection, which is created when the program first begins. And in the load_CD collection function, I've called realloc to reallocate memory that was previously allocated. That allows me to change the amount of memory that I need for storing all the data. But this still doesn't explain how I calculated the number of records in the data file in the first place. Remember, that is done in this function, number_of records in DB. Let's go and have a look at that. And here I am. This is the function that returns that value. Now notice that this function moves the file pointer to the end of the file. It seeks to the end using this constant seek_end, which we've looked at in previous programs. It then calls ftell to return the position of the file pointer. That is, in effect, the total size of the file, because the pointer is right at the end of the file after the previous seek operation. And it assigns this value to the endpos variable. In order to calculate the number of records in the file, I just need to divide the size of the file, that's endpos, by the size of a single CD record. And that tells me how many CD records fit into a file of this size. And this is the line where I do that calculation. When CD records are loaded from a file into the CD_collection array, the total number of records is saved in the variable CD array len. You can see that here. CD array len equals numRecsRead. And this variable is used later when I save the records from the array into a disk file in save CD collection. That's this function here. And you can see there's the variable in fwrite. I declare it as one of the arguments, and I can later test if the number of records that were actually written in count matches the number that I expected to write that was stored in CD array len. Now, in my program, I save this data into a backup file called cd_database.back, and you'll find that declared in main.c. Now, the data saving routine is pretty straightforward. First, I open the file in binary write mode, WB. Then I use fwrite to save the data from CD_collection, with each item having the size of a CD struct and the total number of items given by CD array len. The rest of the code in this short function is used to check that the operation is completed correctly, and then the file is closed and some messages are displayed.